Under the summer sun of the Arctic Circle, men take on the world's biggest ever civil engineering project, the construction of the Alaska Pipeline, a giant 48-inch oil artery across Alaska's rugged interior from the frozen wastes of Prudhoe Bay, where nearly 10 billion barrels of oil wait to be tapped, to the ice-free port of Valdez on the Pacific coast. It's a task unparalleled in engineering history. The figures are enormous. Cost, £2,500 million. Length, 800 miles. Capacity, 2 million barrels of oil a day. Construction time, only 3 years. And nearly 400 miles of the pipeline must be lifted 4 feet off the ground to prevent the heat of the oil melting the fragile permafrost layer which covers much of Alaska. No other pipeline has ever been built in this way before, and it is a task calling for new techniques and new equipment. By far the greatest problems are natural ones. 3 mountain ranges to cross, an Arctic desert, and 3 major earthquake zones. But of all the obstacles nature has put in the path of the pipeline route, the most formidable is the River Yukon. The river forms a natural barrier across which hundreds of thousands of tons of pipe and heavy equipment must pass. The Yukon looks calm and placid, but it's a river that has a rise and fall of up to 30 feet between spring thaw and midsummer. It also has a strong 8 to 10 knot current, which makes the use of conventional ferries impractical. And above all, it's frozen solid for 8 months of the year. Only one vehicle could override all these difficulties, a hover barge. As the barge made its first crossing, it seemed unbelievable that the men responsible had only been in Alaska for 7 weeks. For the first 2 weeks, while the designers were at work in Southampton, they arranged prefabrication facilities with 3 local contracting companies in Fairbanks, 100 miles to the south of the river crossing. With their experience of hover barges, the Mackay's engineers went ahead and obtained the necessary engines, flotation tanks and steel, although they'd not yet received final design drawings from England. There were many items not available locally, and plane loads of ancillary equipment and materials, including the main hover skirts, were flown out from England, while other essential parts were airlifted from the States. Because of the terrible winter working conditions in sub-zero temperatures and the scant facilities at the river crossing, the barges were built in sections at Fairbanks and taken by road to be assembled on site. On April the 15th, on the final day of that demanding 10-week deadline, Princess II was launched. Now the barges had to prove themselves. They were part of the biggest civil engineering project of the century, employing 20,000 men. Men who had worked all over the world, hauling massive loads up mountain roads, across remote deserts, and through tough monsoon conditions. But this was the first time most of them had experienced the unique idea of a hover ferry, and many doubted its capability to do the job. The main pipeline contractor had staked everything on the hover barges. If they failed, there was no easy way of transporting 400 miles of 48-inch pipeline from the south bank to the north bank of the Yukon. And it would be another 6 months before the permanent bridge to carry both traffic and the pipeline across the river was completed. Two powerful cable winches, one to each barge, driven by 290 horsepower diesel engines, are used to pull the craft across the river. 14,000 feet of cable is required for each barge. It passes through a snatch block on the far bank and comes back across the river to the winch. All engine controls are mechanical electrical, as conventional controls using either air or water would seize up under Arctic conditions. They give the barge operator fingertip control of the hovering sequence and were designed and built by Macace. Only when the barge is at maximum hover does the operator signal the winchman by radio to set the towing cable in motion. The journey of just over a mile takes between 15 and 20 minutes, depending on the direction of crossing and the strength of currents. Each barge is designed to take 4 trucks, each carrying 3 80-foot pipe lengths, a total cargo weight of 160 tons. It was estimated that 8,000 truckloads of pipe would have to cross to the northern bank during the pipeline contract. In addition, the pipeline supports many hundreds of tons of equipment for the 11 temporary work camps and 5 permanent pump stations along the northern half of the pipeline route, and huge quantities of food and fuel would have to be taken across the river. Both barges are fitted with double skirts. An inner hover skirt, made up of 160 separate panels, contains the cushion of air, while an outer flexible skirt prevents spray. More than 6 tons of specially developed coated fabric, capable of withstanding temperatures as low as minus 100 degrees Fahrenheit, were used in making the skirts of each barge. An important design factor, as the barges began operation when the river was still frozen, hovering above the ice. As the ice began to melt, the air cushion beneath the craft acted as a natural icebreaker and allowed the barges to operate continuously during the thaw. The advantages of fitting a water spray curtain show clearly when the barge is operating in shallow water. Normally, hover vehicles throw up large quantities of water and shingle on approach to land, but the second skirt eliminates this problem and gives dry working conditions on board. Berthing of hover barges is fast and simple. No special launching or beaching facilities are needed, and a portable steel-framed ramp with wooden decking which can be easily moved up or down the graded approach road to the river according to the height of the water is all that's required. Loading and unloading is extremely rapid. Turnaround times of 2.5 to 3 minutes are achieved. And the record number of crossings to date for one barge is 30 in a 12-hour shift. As fast as one barge offloads, its partner is loading on the opposite shore. Vehicles waiting to get on the ferries are marshalled in parking areas at the top of the loading ramps and called down by radio by the loading master. During the season of the midnight sun, there's no absolute darkness, only daylight and 2 or 3 hours of twilight, and the barges work around the clock. In winter, deck floodlights make it possible for the service to be kept going, despite the fact that for 72 days every year, the sun never rises over the Yukon. Since the barges first went into operation, MacAce engineers have remained in Alaska to undertake the training of local personnel on the operation and maintenance of the ferries. With a 24-hour operational schedule, the only maintenance has been the regular refueling and oiling and greasing of the engines in both the barges and the winches between each 12-hour shift change. The ferries have proved beyond doubt their worth in speeding up the giant Trans-Alaska Pipeline project. No other craft could have done the job as effectively in identical conditions, carrying similar massive loads. In 1 month alone, over 100,000 tons gross weight of trucks and materials were shipped across the Yukon. At peak periods, trucks are being moved at the rate of 160 a day, and very rarely is there an inch of cargo space to spare. Even the old hands of the construction game, the men who had doubted the wisdom of using such an unconventional form of transport, were now singing the praises of the Yukon princesses. The stickers that the drivers display on their vehicles are becoming collector's pieces for truckers from all parts of America. The Hover Ferry and the service road north along the pipeline route are together opening up America's last true frontier. MacAce won the contract to hover the Yukon on their unrivaled record in developing hover platforms for civil engineering, the field in which they are world leaders. They've already carried out other successful operations in Africa, Iraq, the Arabian Gulf, the North Sea, and Europe, and are now developing other uses for amphibious hover platforms, both winch-towed and self-propelled. One possibility with unlimited potential for the self-propelled barge is their use in ports where docking facilities are congested, or to provide a means of transporting cargoes from ship to shore in areas where no port facilities exist. Hovering the Yukon has demonstrated that hover platforms can open up the no-go areas of the world, areas that are largely inaccessible to other types of transport. They have now won the acceptance of the construction industry and the men who work in it.